So this is lesson 5, configuring network addressing and internet connections. I'm going to have some questions at the end. What I recommend is that you ask your own questions and you come up with your own vocabulary list as we go through each slide. Just think about the content, think about the vocabulary, write down and take notes for yourself around topics that come up on each slide. Then at the reviewing the slides, I'll then go over 10 questions and then go over 10 answers. So let's go ahead and get started here. So lesson 5, now we're still in the core 1. We're configuring network addressing and internet connections. The objectives for lesson 5 are compare internet connection types, use basic TCP/IP concepts, protocols, and port configuration concepts. So always remember with the objectives, you want to lock down, focus on those. That is the core piece of knowledge that you're going to need to know. So you need to think about, how do I answer questions related to compare? Those comparison topics are important to analyze. Topic 5A, the first topic within this lesson, compare internet connection types. So on this slide, we have internet connection types and modems, and you have the internet exchange points, XPSs. We have internet service provider, heard about those. Point of presence, POP, point-to-point WAN links, digital modem types, and routers versus modems. So this presentation doesn't do all these different topics. You have to do that additional research to expand your understanding, but it introduces the core topic. So here again, we have the host attached to a switch port or connected to the access point using Ethernet and Wi-Fi to communicate. Right here, and then you have it going into a SOHO router, implements all the functions for local network and internet activity. It's at step 2. And then 3, a digital modem accepts a digital modem adapter in the router connects to an external line. Then you have the 4, the external line connects to the ISP's point of presence. Then you have the ISP's network forwards traffic over internet. So this is the difference between a private and public type of connection. On the left side, you have the host attached to a switch port connected to the access point, use of Ethernet and Wi-Fi. Then on a SOHO network, you have the digital modem, the external line, and the ISP. So just make sure you understand that this slide is all about different types of internet connections, the one on the left being the private, the one on the right being the public. And what is the internet, what is the point of presence, and what are routers versus modems. Internet connection types and modems. So here we have on the left side on a private network, the host attached to a switch port or connected to the access point or on the local private network. Over here on the public side, we have any communications for networks must be forwarded via the router. All right, so that's the difference. We have the public here, must be forwarded via the router. Here on the private, a host attached to a switcher port or connected to the access point or on a local private network. You can see the clients, you see the connection over Wi-Fi, here you see the internet, the ISP, and the connection. So here we have digital subscriber line modems, broadband internet access over last mile copper telephone wiring, asymmetrical DSL, faster download than DSL. We have the DSL modem. We have the DSL modem with an RJ45 cable to router, 11 cable to phone point, splitters to filter voice calls. So here we have an overview of digital subscriber line modems, broadband, asymmetrical, symmetric, and DSL. And we have the image to represent the DSL connection, Ethernet connection. Here we have cable modems, cable access TV networks, hybrid fiber coax, HFC, data over cable service interface specification. That's DOCSIS, data over cable service interface specification. Then we have the cable modem, J45 cable to router, and we have the coax cable with F-type connector to an external port. The coax cable with F-type connector. So here we have with cable modems, hybrid fiber coax, data over cable service interface, and then with a cable modem, RJ45 cable to router, coax cable with F-type connector to external port. So these are evidence of networks that you can check on even in your home to see your RJ45 cable, also how your coax cable connector can connect through a cable modem, all right, or how cable is still delivered to your house for television. So fiber to the curb and fiber to the premises. So fiber to the curb, FTTC, service provider runs fiber to a street cabinet. Very high bit rate DSL overlasts 300 meters or 100 meters. We then have fiber to premises, FTTP, or full fiber. Massive optical network, multiple subscribers. Fiber run to optical network terminal, ONT, installed at customer premises. ONT converts optical to electrical and is connected to customer router. So I've seen this in schools. This is how the fiber comes into the building. It comes in as a full fiber, where fiber to the curb can be fiber that's going to serve multiple locations from that cabinet. Then we have fixed wireless internet access, geostationary orbital satellite internet access. It has high latency, has a digital video broadcast satellite, DVB-S modem. Low Earth orbital satellite internet access, has antenna alignment. And then we have wireless internet service provider, WISP, point-to-point microwave. So here we have cellular radio internet connections, 3G, 4G, 5G. 3G is global system for mobile communication service providers, GSM, subscriber identity module, needs a SIM card, code division, multiple access, CDMA providers. With 4G, long-term evolution, LT, converged standard using SIM cards. And 5G, connection through array of a massive IMO antennas, roaming, and fixed access. So understand the difference between 3G, 4G, and 5G. And here we have routers. Logical network address, internetwork, LAN router, establish logical subnetworks. LAN router connects LANs to the internet, connects LANs across public service provider networks. Firewalls enforce rules for allowed and blocked traffic. Network access control list, ACL, source and destination network addresses, protocol types and ports, allow versus block, enforce rules for blocked traffic. Implementation, dedicated appliance, built-in function of router, network walls versus walls. So here's a review activity, internet connection types and modems, digital subscriber line modems, cable modems, fiber to the curb and fiber to the premise, fixed cellular radio internet connections, routers, and firewalls. So make sure you understand what each of these are, what potentially falls under them, and definitions, and how to understand the difference between everything that you see here. So now we're into topic 5B, use basic IP concepts. So here we have a TCP forward IP graphic with the application, transport, internet, link, network interface. So you have net Wi-Fi, PPP, PPTP, LTTP, the connection with the IP transporting through UDP or TCP into the application, which is maybe DHCP, BootP, DNS, FTP, URL link, a secure server, and other locations on the web. So that's how a TCP connection is basically set up, an IP connection or TCP connection. Then you have IPv4 addressing, 32 binary digits divided into 4 octets. Express each octet as a decimal value, a dotted decimal. So just understand how that octet is broken out as a decimal. And then we have network prefixes. So with network prefixes, we want to know that IPv4 address encodes 2 values, the network ID, the network number, or the host ID, the ID. Portions are distinguished by a network prefix. Bits in prefix set to 1 represent the network ID. For example, 24 bits. See a large number of 1, written as slash notation as /. 24 can be expressed as a subnet mask in dotted decimal. So you see how with the dotted decimal it can be expressed right here. See the /24 network ID. Then we have IPv4 forwarding. Hosts must determine whether destination address is on the same network as its source address. Uses mask to compare network ID and source IP address and destination IP address. Most hosts send traffic for other networks to the router configured as a default gateway. So here we have forwarding with a network ID and the host ID. Public and private addressing. Public addresses are routable across the internet. Private addresses are restricted to local networks. And you'll see them identified below the 3 examples. Address classes and default subnet masks. Internet access for privately addressed hosts, network address translation, NAT, and proxy service. So just make sure these are concepts that if you're not familiar with or you're not super strong on what they are or how they're being applied, just write these down so that you can review them later and go back to them. Don't let the fact that maybe you don't understand the concept slow you down. All I'm saying. IPv4, host address configuration. IPv4 address and subnet mask. First IP and range is network address. Last IP is broadcast address. Hosts can be assigned network addresses in between. Default gateway, domain name server. Domain name system, DNS server address. So here you see the configuration for the IPv4 address and submask, the default gateway, and the domain name server address. And then you see the screenshot from Microsoft. On IP, subnet prefix, gateway, preferred DNS. We have this host address configuration, uses and disadvantages for static addressing. Understand what they are. Dynamic host configuration protocol, DHCP. Understand what that is. Automatic private IP addressing. Make sure you know what that purpose serves. And also understand 169.254.x.y. Look it up to make sure you understand it. Here we have the setup of a DHCP server within TP-Link, just as a image. That brings us into the SOHO router address configuration, particularly with a TP-Link, which is common for a SOHO network. Router's LAN interface, a web management interface, so you can interface it from just a website. Administrator password, a router's public WAN interface, static versus dynamic addressing, line protocol settings and monitoring. Addressing, IPv6 address format has hex digits and length 64-bit host identifier. Then we have a network prefix mask, first 64 bits. Global and link local interface addresses. Global addressing start with 2 or 3. Link local addressing, the FE80. Static address alignment versus stateless address auto configuration, SLAAC, SLAAC. Dual stack hosts operate both IPv6 and IPv4 at the same time. So the topic of IPv6 addressing obviously has a couple topics here. There's the address format, you have the network ID and the interface ID at 64-bit. You have network prefixes, which have the fixed link host identifier, mask the first 64 bits. You also have the global and link local interface addresses, SLAAC static address assignment, and also 6 and IPv4 at the same time. So make sure you go back over those concepts, make sure you understand them. And here's our review. Understand. So maybe start off with flashcards of understanding good topics, and then you can kind of have your knowledge for the questions so you can handle questions really well. IPv4 network prefixes, IPv4 for public and private addressing, IPv4 host dynamic host address configuration, IPv6 addressing. So just make sure you go back over those and understand those TCP IP concepts and can review them. And of course, this is a great activity to understand how a SOHO, a great activity here is definitely to understand how to configure a SOHO router, basically a home router for your network, a small office router. Use the GNS3 network simulator to configure a home network. So definitely check out the GNS3 website that allows you to types of networks. So definitely check that out. And then let's keep moving into topic 5C, compare protocols and ports. We have the transport layer, identify each application protocol, track sessions, and we have protocol ports, server port, client port. So if you take a look at this graphic, we have one here, host 2.2 and 2.3 send different types of traffic to the host. See that? This traffic is sent over the network as a layer 3 packets encapsulated in layer 2 frames. Host identifies each type of data from application processing. So these are protocols and ports, and the protocols for when data is being sent over them. So make sure you understand what a server port is, a client port, protocols, and what sessions are. Transmission control protocol, connection-oriented transport protocol. It's about establishing a connection, assigning each packet sequence number, allow the receiver to acknowledge ACK, which you're going to see a lot in tech, allow the receiver to send a negative acknowledgement, NAC, allow the termination of a session. TCP-based application protocols, hypertext transfer protocols, secure HTTPS, and secure shell SSH. So those are TCP-based applications and what they can do. And here you see a screenshot of Wireshark. User datagram protocol, connectionless, unreliable delivery, smaller header, UDP-based application protocols, dynamic host configuration, DHCP, understand what that is, trivial file transfer protocol, TFTP, UDP-based application protocols. So the user diagram protocol, here you see it, source portal, data portal, distributed portal, is a smaller header mean, and why a UDP-based protocol. And why would you use a dynamic host configuration versus a trivial file transfer protocol? It's a datagram protocol, user datagram protocol. So here is a list of well-known ports for networking, remote access, file transfer, and of course, email. So you'll see these commonly in setups and configurations for, email servers here, file transfer, so whether it's secure, FTP, or just over the web. Then you have remote access, like SSHing into something, or remote, or telnet. In networking, we have DNS, DHCP, NBT, SNMP, and LDAP. So all sorts of different types of ports. We're doing different types of processes. Make sure you understand where each one falls in its own little family. It's email, file transfer, remote access, or networking. So as a review activity for protocols and port, important, transmission control protocol, user datagram protocol, and well-known ports. All areas to review and make sure that you are aware of each one of them means. And then as we move into our final section here, we have topic 5D, compare network configuration concepts. And once again, I remind you that as you listen and go through this, you should be taking notes. You should be asking questions for yourself. Make sure that your ideas, that your strengths and your weaknesses. Everybody has strengths. Everybody has weaknesses. What is vocabulary that you're seeing that you need to know better? How will you go back and review it? How will you determine whether or not you know it? Now we have dynamic host protocol. We have the DHCP scope, a range of addresses in a subnet offered by the server as leases. Then we have the DHCP leases, discover, offer, request, called DORA, discover, offer, request, and knowledge. Then we have UDP 67 server port and UDP 68 client port. Those are the DHCP leases. And then we have DHCP lease the same IP address based on the client's MAC address or other interface identifier. So here's a little review here. They have this image. Number one, we have the DHCP discover, DHCP request, DHCP offer, and DHCP ACK. Now there's a MAC address with each one, and you can see how they travel back and forth. So just make sure you understand those as parts of a dynamic host protocol. Then we have a domain name system, DNS. Resolve friendly names assigned to hosts to IP addresses. There's a host name and there's a fully qualified domain name, FQDN. We have the DNS hierarchy with root servers, top level domains, and the domain names. So here you have the root, the dot, top level domain, com, net, UK, country code, some domain, which could be country. And then we have the domain 515 support, potential subdomain of corp, and they could be a www.net address or .com address. Understanding goes up from there that it's a corp or it's a domain, and it kind of gets all the way back to the root. That's basically also how websites work. So make sure you understand domains, the host name, the fully qualified domain name, root servers, top level domains, and DNS hierarchy. Here we have DNS queries. We have one client queries 515web.net. Local name server is not authoritative for .5015 does not have a cache record. It is configured to perform recursive querying, and so contacts a root server until a pre-configured address IP addresses. So root server is not authoritative, but is not authoritative for the record, but returns a server for the .net TLD top level domain. That's one option. .net TLD is not authoritative, but returns the same server for .5webnet. Then we have the .515web.net name server is authoritative for the domain and returns requested host record 5. The local server caches the record in response to the client. The client now has an IP address for the .5webnet, which it caches. So that's the entire sequence of querying, finding the domain, the web name, finding the root server, and eventually you have the web server is authoritative for the domain and returns the requested 515web, and then the local server caches the site. So a little bit about what a DNS query looks like. Here we have DNS record types. Address records, a record resolves to an IPv4 address. An record resolves to an IPv6 address. Then we have MX records, a mail exchanger, identify address record providing mail services. Can create multiple records with high priority values is highest priority. Then we have DNS spam management records, text to store free form font text to support services. DNS can record authenticate data for the domain's mail servers. Recipient can check these records to block unwanted and spoofed messages. Spam management, sender policy framework, SPF, host identifies host authorized to send mail. Domain keys identified mail, DKIM, uses cryptography of mail source. Domain-based message authentication, reporting in conformance, DMARC, framework to ensure that the SPF and DKIM are being utilized effectively. So that's the DNS spam management records. So here I would recommend just focusing on terms like text, DNS, spoofed messages, how they happen, SPF, DKIM, DMARC, and what they mean and how they're different. Then we have virtual LANs, divide local network into separate broadcast domains configured on main switches, network administrator general. Each switch port can be configured with the VLAN ID, so it has its own number. Switch ports with the same ID are in the same VLAN and broadcast domain. Unconfigured switch default to VLAN ID number 1. Traffic between VLANs must be sent via routers. Virtual private networks. Join a local network from a remote location. A local network traffic is over a public or untrusted network. Uses authentication and encryption to prevent unauthorized access. So here's a little graphic. The VPN client host connects to a VPN gateway using any type of internet subscriber access method. 1. The VPN gateway authenticates the user and creates a secure, and they get the remote access. Then eventually onto the local network through VPN client traffic is routed over the network and can authorize access authorized services. So once it gets from the remote access screened subnet onto the local network, it can then access the services authorized for a VPN to connect to. So the review activity configuration concepts is one very valuable for flashcards in the terms and understanding how they work together and what you might expect to see. Dynamic host configuration protocol, domain name system, DNS queries, DNS record types, spam management records, virtual LANs, virtual private networks. So those are the terms that you're going to want to make sure and can differentiate the differences between. So that's the summary for lesson 5. I think it would be good to go back through each concept that you see here in this lesson, review it, make some flashcards, do some review of all of the topics, make notes of what you don't understand, write down vocabulary you need definitions for, that you need to prepare and study for, understand different domain name systems, figure out configuration of everything that you see on each slide. How is it configured? Why is it configured that way? Get down for yourself, okay? You can understand all the central concepts here. I'm just scrolling back to the beginning. And what I'd like to do, I appreciate you lesson and spending time with me. And what I'd like to do now is go over some questions with some answers and give you some time to kind of them. The questions first. There's only 10 questions. And I'll do the 10 questions. And then what I'll do is I'll review the answers. So here I'd like to go over some questions. I'll go through them slowly. I'll review them. I'm going to do the questions, and then we'll go through and we'll repeat each question, and then we'll go over the answer, just so you know what the answer is. So the very first question is, this is for lesson 5, configuring network addressing and internet connections. Which port does the DHCP server use to listen for client requests? And they have UDP 53, UDP 67, TCP 25, UDP 161. All right, we're going to move to the next question. A technician needs to assign us to a device on a SOHO network. Which settings are required? Host name and SSID, MAC address and DNS suffix, IP address, subnet mask, and default gateway, FQDN, and VLAN ID. So for the static IP on a SOHO network. All right, I'm going to move to the next one. What address range is used by APIPA when a device cannot reach a DHCP server? 192.168.0.0/16, 169.2540/16, 16.0.0/D0/12. Which of the following So which one of those is it? And just used by APIPA. Device cannot reach a DHCP server. Just always make sure you reread the question. Which of the following describes the function of a DNS MX record? Maps a domain to an IPv4 address. Maps a domain to an IPv6 address. Identifies the mail server. Resolves host names to MAC addresses. So which of the following describes the function of a DNS MX record? Let's go on to question 5. Which internet connection type is by high latency? Fiber to the premises, FTTP, cable, or satellite? Which one is most affected by high latency? So you need to know what latency means. You need to know the benefits and the weaknesses of these networks. A user is connected to the internet through a 5G mobile hotspot. What type of internet connection? A fixed satellite, wireless, fiber, cellular, radio, or satellite? All right, let's keep going. I'll scan through 10. Which protocol uses TCP/445 for file sharing in Windows environments? FTP, SMB, Telnet, or SNMP? TCP/445 for file sharing in Windows. Which of them really connect to a company's internal network over the internet? VLAN, RDP, NAT, or VPN? That's definitely on the CompTIA exam. So just pay attention to questions like that. Which is the primary difference between TCP and UDP? TCP is stateless protocol. UDP is stateful. TCP uses encryption. UDP does not. TCP provides connection-oriented communication. UDP is connectionless. UDP uses port numbers. TCP does not. So which is it? Our final question is, what feature of VLANs helps reduce broadcast traffic on a network? And I remember just going over encrypting packet dividing the network into smaller broadcast domains, using dual band radios, finding private IP addresses. Which feature of VLANs helps reduce broadcast traffic? All right, let's go over our answers. So our first answer is UDP 67. So which port does this DHCP server use? UDP 67. All right, let's go to question 2. C, IP address, subnet mask, and default gateway. These are the correct answers. Which settings are required? IP address, subnet mask, and default gateway. All right. B, 169.254. Let's take a look at it. 169.254.00/16. PIPO, when a device cannot reach a DHCP server. Went too far. C, identifies the mail server responsible for mail delivery. So most affected by late satellite is the most affected by latency. Now, 5G hotspot, cellular radio, right? So we have SMB and then VPN. So SMB is the port 445, TCP 445 for file sharing in Windows, and then VPN, just like I mentioned, you should need to know that one. Definitely on the exam, the VPN. All right. So again, let's look at 9 and 10, C and B. So let's look at these answers. The point of doing this is just a quick way of reviewing the content that you can then do again on your own, a video or taking notes. So watch the video, take notes, think about topics you don't know, then go through these questions. As I read them the first time, try to answer them properly. Then go through them, review your answers, take notes of the ones that you didn't know very well. Make sure that you kind of concept. Here for number 9, we have TCP provides connection-oriented communication, UDP is connectionless, and 10 is dividing the network into smaller broadcast domains. So a quick like, so you get a chance. I'll share the documents on my website here so you can review them at your leisure. Feel free to connect with me. Thanks for watching.